So our next problem again is from the MIT 2023 Integration B semi-final number 1, and this is problem 4. And it's the integral, indefinite integral of 3 log x natural logarithm x minus 1 plus 2x over x times natural logarithm x plus x squared plus 2x to the power 4. Now, looking at this problem, I think the first painful thing that I would want to get rid of is the natural logarithm x. So what I would do here is I would substitute for log x with u. So we say let u is equal to log x. And what that means is that du dx is 1 over x. And if I multiply x to both sides, it means that x du is equals to dx. Now, since u is equals to log x, then x is the same as e to the power u. So that means that eu from here, e to the power u, du is equals to dx. Now, bringing in this whole integral here, we can substitute where we find log x with u, and then when we find x, we substitute with e to the power u. So the integral now becomes 3u minus 1 plus 2 to the power times plus 2 times e to the power u over eu times u plus e to the power 2u plus 2 times e to the power 4u times e to the power u du by substituting for dx here. Now this eu can cancel out with one of the e to the power u's in the denominator, and so the expression now becomes 3u minus 1 plus 2 times e to the power u over u plus eu plus 2 times e to the power 3u. So we can try to exploit the derivative of a natural logarithm of a function. And we know that when we try to derive or differentiate the natural logarithm of a function, fx is the same as the derivative of a function fx over the same function fx. So if we look at the denominator of our integrand here, and if we want to focus on its derivative, the derivative of u plus e to the power u plus 2 e to the power 3u is the same as 1 plus eu plus 6 times e to the power 3u. So if we would have to reorganize the numerator here to contain this so that we can take advantage of the natural logarithm function. So 3u minus 1 plus 2 times e to the power u over u plus e to the power u plus 2 to the power 3 u is the same as we take the negative 1 this side, and the 3u remains here, and then we split the two EUs such that so we have one EU on this side, and since we are looking at the negative sign here, we have 3 EU here, so that 3 EU minus the e to the power u, we get 2 here. So in this function here, if we straightly integrate it, we would get a natural logarithm of the denominator here. Now let's play around with what we've created here. So when we pull out the 3 constant here, we see that the numerator and the denominator are the same. So essentially they would cancel out, and our function now becomes the 3 times the integral of 1, and then minus the integral of 1 to the power plus e to the power u plus 6 times e to the power 3u over u plus eu plus 2 times e to the power 3u. So this now means that the integral is 3u minus logarithm, natural logarithm of u plus e to the power u plus 2 times e to the power 3u plus a constant. Now, since this is our answer, we'll have to go back and rehash the fact that we substituted u in place of log x. So that means that when we substitute for u in this answer here, the integral of our original function is now 3 log x in place of u minus log x in place of u plus x. E to the power u is the same as e to the power log x, and e to the power log x is the same as x, plus 2 times 3 at the power times e to the power 3u, which is the same as 2 times e to the power au cubed, so it's 2 times x cubed plus c. So this is the final answer. Well, thank you very much for joining us tonight again. This was a shorter problem, but all the same interesting. For those of you who haven't subscribed to our channel, again, I urge and beseech you to subscribe so that you get a notification every time we come up with a solution to some of these very interesting problems. Thank you again. Until next time, tout à l'heure.